This video will cover the concept, finding the limit involving infinity using a numerical approach. Recall the definition of a limit. A limit is the value that a function approaches as the input approaches some value. In this topic, you'll be presented with limit problems that involve positive or negative infinity as the input or the output. Let's review some function language from your previous math courses and make sure that you recall the meaning of inputs, outputs, domain, range, in regards to functions. The values of x that can be used in the function are called the inputs. All of the input values taken together are called the domain. The values of y that the function generates when the input numbers are used are called the output numbers. And all of the output values taken together are called the range. Now we will solve one of these problems involving infinity as the input using the numerical approach. Using infinity in this way may be a new topic for some of you, since most of us are accustomed to using numbers as inputs, and infinity is not a number. Positive infinity represents something that is larger than any real or natural number. Negative infinity is the opposite of positive infinity. For the numerical approach, we will use a table to find the values of f of x as x gets closer and closer to infinity. We will substitute x values of 100, 1,000, 10,000, and finally 100,000. Doing so provides the following y values. What y value do we get closer and closer to as we substitute larger and larger x values?
The y value gets closer and closer to 4.
That's correct. Therefore, we can determine that the limit as x approaches infinity of this function is equal to 4. Let's do another example. In this example, we need to find the output of the function as x gets increasingly closer to -3 on the right side. We want to make sure that we arrange the x's in the table so that their values decrease and get closer and closer to -3. This means we want to substitute numbers slightly greater than -3 into the function, like -2.9, -2.99, -2.999, and so forth. Doing the math, we get y values that grow closer and closer to -infinity.
Does this mean that as x approaches -3 from the right side, that the outputs get smaller and smaller?
You are right. Do you know how we can state the answer in another way?
Can we say that the answer to this limit problem is -infinity?
Yes, that's correct. We use -infinity to denote that the limit decreases without bound.